that I can upload. The idea of substitution, though, is if I have x or y and I know its value, even if I don't know the numeric value, but if I have x equals something in one of my equations, then where I see x in the second equation, I can, in this case, take the x out and replace it with the 7 because they're of equal value. Now, notice in this second equation, everything that is outside of this circle is going to be recopied exactly as it looks. But the x is going to be replaced with 7 because they are of equal value. And again, if you need to pause this video to catch up on copying things, if you need to rewind and listen to something again, please feel free to do that. At this point, now I'm just going to solve my equation for y. So 14 plus y equals 5. I would subtract 14 from both sides of the equation and get y equals negative 9. Now when I'm solving a system of equations, I'm trying to say if I graphed the vertical line x equals 7 and this line, where's their point of intersection? So my solution is the ordered pair 7 for x, because it tells me x is 7, and negative 9 for y. So if I graph these two lines, they should intersect at the point 7, negative 9. Now the check that you are required to show goes back to that first learning target. I'm going to take my first equation, my x equals 7, and from my ordered pair, my x is 7, so I plug it in for x. Yep, 7 equals 7, so it checks in the first equation. I take my second equation, 2x plus y equals 5. I'm going to substitute 7 from my answer for x, negative 9 from my answer for y. So I substitute x and y values in for x and y. The right side of the equation stays 5. Make sure you copy this down. And then you take your calculator and you plug the left side of the equation into your calculator. 2 times 7 plus negative 5 is 5. Yep, both sides of the equation are equal to each other, which means that point is on each of those lines. So it is the point of intersection of those lines, and that is my answer. The second equation, y, by itself, has a value of negative 2x plus 7. So where I see y in the second equation, I can remove it and substitute negative 2x plus 7 in its place. Now notice again, everything outside of this circle in the second equation, the equals and the negative 3 just gets copied down. But this y is going to be replaced with negative 2x plus 7. I would subtract 7 from both sides because I'm going to solve this equation. So negative 2x equals negative 10. And then to solve for x, I would divide both sides by negative 2. So x equals 5. So I know my point of intersection, my solution, the x value is 5. And in this case, they told me the y value is negative 3. So I think my point is the point 5, negative 3. You have to show your checks now. So for your checks, I'm going to copy my first equation. Y equals negative 2x plus 7. I look at my answer. My y, which is the second part of my ordered pair, is negative 3, equals negative 2 times my x is 5, and then bring down my plus 7. So again, all I did was take this equation. My y from my answer was negative 3. My x from my answer was 5. Simplifying both sides, I can't simplify negative 3, but negative 2 times 5 plus 7 is negative 3. It works in that equation. The second equation, y equals negative 3. Well, substitute my y value in for y. Negative 3 does equal negative 3, so it checks there too. My third equation, y, has a value of negative 2x plus 14. So where I see y in the other equation, I'm going to substitute negative 2x plus 14. Notice everything outside of that circle is going to be recopied, so equals 3x minus 16. Now I am going to speed up my work a little bit. I'm going to talk you through it though. If I want to solve this equation, I want my x on the left, so I don't want this positive 3x on the right. I would subtract 3x from both sides of the equation, and I get negative 5x plus 14 equals, pay attention to your sign, negative 16. Then I would subtract 14 from both sides of the equation to eliminate the constant on the left, and I have negative 5x equals negative 30. And last but not least, to solve for x, divide by negative 5, so x equals positive 6. Now the difference between this and my previous answer, so I'm going to circle that previous answer, is I know that the x value of that point is 6, but this is different, and they didn't just give me a numeric value for y. But what I do know is that y equals negative 2 times whatever x is plus 14 from one of my equations. It doesn't matter which one. And I now know that x is 6. So negative 2 times 6 plus 14 is going to be my y. Plug this in your calculator. Negative 2 times 6 plus 14 is 2. So I believe my y is 2. Now my checks start with my y equals negative 2x plus 14. Looking at my answer, I'm going to substitute 2 for y and 6 for x. And then you're going to grab your calculator. Negative 2 times 6 plus 14 is 2. Yep, both sides equal 2. It checks in the first equation. But you guys should know I'm not showing that it's the solution unless I check it in both equations. So again, looking at my answer, my ordered pair, my y is 2, my x is 6. So 3 times 6 minus 16 is 2. Yep, it works in both equations. So this is my solution. I'm going to circle it and go on to my next answer. Y has a value of 2x plus 5.5. So where I see y in the second equation, I'm going to substitute 2x plus 5.5 in its place. Now, notice again, everything else outside of this circle, the 3x plus 8, I'm going to put a big set of parentheses where the circle is, and the equals 6, everything outside of that circle gets recopied. But the y is replaced with 2x plus 5.5. I'm going to do some distributive properties, so 3x plus 16x plus 44 equals 6. I'm going to do two different things here. Again, I've got to kind of move a little quickly. I'm going to subtract 44 from both sides to get rid of this plus 44. It's going to be a negative 38 when I subtract 44 from both sides. And then my 3x plus my 16x on the same side are 19x. Then when I divide both sides by 19, my x is going to equal negative 2. So I can actually start my answer. Negative 2 is my x, and now I need to find my y. But I know that y equals 2x plus 5.5, and I now know that my x, if I did that correctly, is negative 2. So I'm just going to substitute negative 2 in for my x, which means y equals 1.5 by the time I plug this into my calculator. My checks, I start with my checks. Y equals 2x plus 5.5. I know that my y is 1.5. My x is negative 2. So 1.5 equals, plug this in, I get 1.5. It checks in the first equation. And then the second equation would be 3x plus 8y equals 6. Well, x I think is negative 2. Y is 1.5. The right side stays 6, and when I plug this in, I get 6. It works in both equations. Now, I'm not going to show the checks on the next two. You should still be putting your checks down. Remind yourself, please, it's going to help you a lot. This is like 4x minus 1y equals 20. So when y by itself has a value of 2x minus 8, where I see y in this equation, everything else is going to get copied down. The 4x minus 1 times something, and the equals 20. But the y is going to be replaced with 2x minus 8. Some distributive property is going to get 4x minus 2x plus 8, because it's like a negative 1 times a negative 8 equals 20. When I subtract 8 from both sides, I'm going to get 12 on the right. And when I do my 4x minus 2x, I get 2x. When I divide both sides by 2, x is going to equal 6. So my answer is going to be 6 something. I'm going to go back and circle that previous answer. I know that y, looking at my equation, is 2 times x minus 8. And I now know that my x is 6. Again, pause, rewind, slow this down as you need to. So y equals 4. I don't have time to show the check on this, but if you want me to do that in class with you, I can. So the point is 6, 4. Y by itself has a value of 3x plus 11. So where I see y in this equation, I'm going to substitute 3x plus 11. So that equals negative 2 times 3x plus 11 plus 8, which means x equals, doing some distributive property, negative 6x plus 22, bring down my plus 8. Remember, this is a 1x. So when I add 6x to eliminate this x term on the right, and then I add 6x over here, it's going to become a 7x. And then I add these terms together, my 22 plus 8 is negative 22, sorry, minus 22 plus 8. Negative 22 plus 8 is negative 14. So if you didn't catch that mistake and fix it already, negative 2 times positive 11 is a negative 22. All right, equals negative 14. Divide both sides by 7, x equals negative 2. So my x is negative 2. I know that y equals 3 times x plus 11, which is what that first equation says. And I now know that my x is negative 2. Sorry, this writing pad is having some issues. So 3 times negative 2 plus 11 is 5. My y is 5. Please watch the part 2 of this video that I think I'm going to have to do to get these special cases done.